Alright guys, so in this video, this is an additional video and this is going to cover the crossover method for ionic compounds. So this only works for ionic compounds. Remember, that's a metal and a non-metal. I decided to teach you this separately because if you can see in the booklet, if you go to page 54, which is where we're up to now, believe it or not, we are that far, you might need to use the crossover method to determine the products in future. It really depends on how they ask the question, but it's important that you can do this so that you're not stumped by any of the things that we cover later on. I'm going to take you through this video. I'm going to teach you how to use the crossover method, how to make it work with oxides, how to make it work with polyatomic ions, how it will look in equations if you want to work things out to balance them. And then hopefully once you've developed this and practiced this, you can learn the skill of crossover method, which will teach you how to basically balance most ionic compound equations that you ever get given. Now, this means that you probably do have an extra video now compared to my actual original plan, but it means that the next videos are going to be really, really short. So let's just get straight into it. So this is called the crossover method, and we will refer to this in class. And I just want to show you straight away how this works. So if you have an ionic compound, let's take aluminium oxide, for example. If I was to ask you what's the chemical formula for aluminium oxide, you might come up with something like ALO, but that's not correct. So there is actually a way to do this, and I've started with aluminium oxide because it's a bit trickier, but I want to teach you how this works. So if I'm producing a compound called aluminium oxide, aluminium is a metal, and oxide is a non-metal, which means it will be ionic if it's together. Now we use something called the crossover method to determine this, and we're going to use this quite a bit, so please follow along. First of all, we've got aluminium, and then we're going to write oxygen next to it, just as the element, just like this. Now we look at the charges that they could possibly have. So aluminium is in group 3, so this is going to be 3+. Oxygen is in group 6, which means it needs 2 electrons, it'll be 2-. I've given you quite a complicated example to show you how this works, but let me explain. So the crossover method is where we cross over the numbers. So I'm going to draw a line here, and then a line here. Doesn't have to be precise, it's just going to show you what we do. And now I'm going to rewrite aluminium. I'll leave a space, and then I'm going to write oxygen here. And now we look at the numbers. So the value, this is 3+. We only look at the number of the charge, not the actual representative of the charge. So this is 3. So I'm going to put a 3 here. This is a 2. So I'm going to put a 2 here. And then I'm going to put them together. And aluminium oxide is Al2O3. And just so you can see this works in reverse, let's have a look at that, assigning oxidation numbers. Oxygen is 2-, and I've got 3 of them. So 2-, 2-, 2-, so 6- overall. Aluminium is in group 3. When it's bound, it becomes 3+, and I've got 2 of them. So that's 3+, 3+, 6+. And these cancel each other out, which means this is correct. I'm going to show you one more example before I go on to a different type. I've got calcium hydroxide. Now, hydroxide is a polyatomic ion, and you'll see that over here. So these are the polyatomic ions that I've asked you to kind of remember as we've been going through this course. These are the ones that have 1 charge, ammonium being a plus. These are the ones that have 2 charges, 2-, and these are the ones that have 3, which is phosphate, and probably the only one you guys are going to run into. Let's do calcium hydroxide. The rule with polyatomic ions is these are best friends. They stay together. So we don't look at O separately and H separately. Hydroxide is the thing. So these two stay together. We don't ever separate them. We balance them together. We move them together. We count the charges together. Let me show you. So we've got calcium hydroxide. This is a base. And we're going to learn more about bases later on. But let's have a look at how we will write this. So calcium, just Ca, and hydroxide, like I said, is together, is OH-. Calcium is in group 2, so this will become 2+. Crossover method. Line here, line here. I rewrite calcium. Let me do it in a different color so you can see this. I'm going to have calcium, and then we're going to have hydroxide, just like that. Let's have a look at this value. How many charges do I have there? 1. So I only need 1 calcium. How many charges do I have here? 2. So I need 2 hydroxides. So I put a 2 here. That is incorrect. This is OH2. That's water. That's not what I want. What I want is 2 of these, so O2, H2. But then that's also incorrect and doesn't make any sense. I need those two to be together. To show that I'm going to double everything, we put this whole thing in brackets. And that means I have 2 oxygens and 2 hydrogens, or ultimately 2 hydroxides. So what this says is I've got OH and OH, which is what I want. If I have O2H2, what I'm saying is I have God, this is going to be weird. I have something that looks like this. This doesn't exist, so that can't be correct. And then I could also have OH2, which is just this. And that's just water, but I need 2 of these. So that's why we use the brackets to show that we have 2 of them. And that's how we do the crossover method for calcium hydroxide. The next one I'm going to look at is a reaction. So this time we can determine the reaction and then we can balance it. We've got gallium and chlorine. We're going to react those 2 things together. You've not come across gallium before, but I can tell you if you look on your periodic table, gallium is in group 3. It's just below aluminium, which means it'll also be 3+, just like aluminium. So let's have a go at doing the crossover method to see what the product would be for this. So we're going to react these 2 things together, and we're going to make gallium chloride, which means I need to do the crossover method for this. Ga, chlorine. Gallium is in group 3, so that's 3+. Chlorine is in group 7, so it's going to be 1-. Crossover method, GaCl. I have 1 charge for this, so I only need 1 gallium. And then over here, I've got 3 galliums, so therefore I need 3 chlorines. Chlorine's just an atom on its own, so I make gallium chloride like that. So that's GaCl3, which looks very, very weird. But there's going to be my answer. So I'm going to put that there like that. Now, the next step is to balance this. Easiest trick to start with balancing, look at the metals. Do the metals balance? Yes. What's the next? Chlorines. Right, this is where it becomes an issue. So with the chlorines, I've got 2 over here and 3 over here. I am not a fan of balancing things when I have an odd and an even. So let's just make it even. And what I'm going to do that, I'm just going to double this. If I double this, it means I've also doubled my gallium. So let's put a big 2 on that. But now I've got odds. So now I've got 2 and 6 chlorines. This is much easier to balance because if I've got 6 over here and I've got 2 over here, that just means I need to multiply this by 3. And that is the easiest trick that I've found to balancing these equations. You won't likely have to do all of that in one go, but you will have to do parts of it. And it depends on which parts of it they ask you. Now let's have a look at one other example. So this time I'm reacting a metal with an acid. We'll cover acids later on, but we're going to look at a metal and an acid, and it's going to produce hydrogen gas and something else. That something else can be determined by what we have over here. And you're going to learn more about this in acids, but I'm going to make potassium phosphate. So I need to do the crossover method to make sure I can produce potassium phosphate. So potassium, and then phosphate. Remember, PO4, our friends, they stay together, PO4, and this has a charge of 3-. You just need to remember this, I'm afraid. Right, let's cross over these. So this is going to be 1+, so I'm going to cross this over, K, and this is going to stay together, so let's just put it in brackets straight away, because we know that's going to stay together. Right, over here, how many charges do I have? 1. I've only got 1 charge, so I only need 1 PO4. Doesn't need brackets then, but let's just keep those brackets there for the sake of it. And then over here, how many charges do I have? 3, which means I need 3 potassiums. So this time, I have potassium phosphate, but it's K3PO4. And let's just move that up there. Now I need to balance it. Let's have a look at the metals. Over here, I've got 3. Over here, I've got 1. Dead easy. Put a big 3 in front of that. Over here, however, I've got 3 hydrogens. And then over here, I've got 2 hydrogens. And you know what I said before, I don't like balancing that. So let's just remove that out of the way. Let's make this even. Put a big 2 in front of this. Now I've got 6 hydrogens, and over here I've got 2. So I can put a large 3 in front of that, and now my hydrogen's balanced and I'm happy. However, I doubled the PO4. Notice I didn't say I've doubled the P and I don't have 8 oxygens. PO4 we balance as one thing. We keep it together. I've got 2 PO4s on this side. How many PO4s have I got on this side? 1. So I'm going to put a large 2 in front of this one. You can see that already is 2, 2, 3. And now what's changed? The PO4 is now balanced. However, now I've got 6 potassiums, which is why I went back to remove that other one. And then finally, put a big 6 in front of there, and we've got that. You will never be given anything like this to balance, so I wouldn't ever worry about that. But I just wanted to show you how the crossover method works in practice. I've also got a periodic table here snipping, just to show you that we've got gallium here, which would be 3+, and we could have something like calcium, which would be 2+, and then we just use the periodic table to determine how we do that crossover method. Right, guys, I'm going to cut the video here, but then we're going to go straight on to the next video where we look at actually putting those reactions to practice.